can this data tell us? Because obviously I worked with the data the closest. I knew this data is a gold mine, let me be honest. And I knew there's so much you can do with it. And there's so many experiments that I did, but I just didn't have time to really follow it through. Like in terms of trying to build machine learning detectors, do DGA and detection. But you know, I like my investigative work. So I just focused on that. And I just asked the question, how effective are botnet takedowns on malware delivery? And obviously this is a question that's been asked already for the last decade and a half. Then there's studies out there. But what was unique and what I thought would be useful is because we have this unique perspective and we've already found some things I hadn't seen before. Let's see what we can find by focusing on a botnet that we knew was taken down. And let's just see what happens. I'm sure everyone knows what these are, but a botnet, I just had this in the original presentation, is a network of malware-infected devices controlled by an actor. Takedown is just any offensive technique used to disrupt a botnet, and usually carried out by law enforcement, security researchers, companies, Microsoft being, you know, the most well-known one. So in terms of methodology, so it's more or less similar to what we did before. As you can see, I've added fully qualified domain names because I just realized that helps get a better representation. What else do we do? So, okay, so each 25, so this is again dynamic analysis. So we want to look at long-term dynamics. So for each 24-hour graph snapshot, we do a similar thing. So we've got a network, we do the assignment of labels. I start to show off my presentation skills here. Then what we do is, so we've got two malware there, or sorry, I'm having some screen issues here. So we've got foo and bar. They're two unwanted software families. They may not even be both malware, one could be pup. But here we care about specific operations. So we want to focus, let's say foo malware, we want to understand that operation. So in this case, we aggregate all the nodes that have been labeled as the foo malware, and that's going to be our target family because that's the target operation we want to study. Next thing we do is we basically aggregate all of the nodes that are linked to this family. Linked to this target family. And because those nodes, we know that they represent the delivery infrastructures. And then once you got that subgraph, sorry, jumped twice. Once you got that subgraph, you've basically got the global delivery operation of this particular target family. And trust me, as a data-oriented person, you can compute any time series metrics you want on this subgraph and use that to get to understand one facet of the operation in the real world. And again, trust me even more, I create 20 metrics because I like numbers. And yeah, just to run through the categories here. So we've got aggregate network activity, evasion indicators, aggregate download activity, relational dynamics. When we say relational dynamics, so how many different other types of malware is being, is related to this target family, either in delivery or being delivered by them. We've got distributed delivery indicators. So if they're using multiple servers to be delivered, and of course multiple countries. In fact, that kind of links to the aggregate network activity. And then we also got polymorphism indicators. So malware and polymorphism talks about the ability of malware to represent itself in different ways and obviously beat detection systems, like changing hash or doing some other behavior, but the end goal is still achieved. More presentation skills show off. I think I started to like using the animation feature in PowerPoint. But what I'm trying to show besides my skills is obviously I like visual stuff, and visuals is really how I was able to do this analysis, really just breaking up each of the metrics, and on each column is actually a malware operation. You can see them now, in fact, Dridex, Dorkbot, and Upatre. And it just gives, a picture tells 1,000 words, and that's exactly what you did in this study. And yeah, there's not much else to say on that. So operations, you've already seen it. So Dridex is the first one, is a banking Trojan. And at the time of the study, which was done last year, it was only known to operate as a payload. So it's never been known to deliver other malware, for example. So the takedown operation that was carried out against it was a 60-day DNS sinkhole and disinfection campaign from early October 2015, and it was led by the FBI. Basically, DNS sinkhole, disrupting the communication channels between the infected computers and the command and control servers and the intermediate infrastructure. And basically it sinkholes all of that traffic to servers controlled by the FBI. And a disinfection, obviously removing the malware from the devices. Something worth noting, keep in mind, 2 other takedowns occurred literally just before this one. And in fact, they were carried out by the FBI and the NCA from the UK. So just keep that mental note for one of the results I'll share. Dorkbot, and this one's a family of worms known to steal data and basically just do all sorts of bad stuff and distribute other malware. The takedown was a DNS sinkhole and seizure in December 2015 by a collaboration of security companies and law enforcement. Again, similar thing, the seizure aspect is them physically seizing the infrastructure, so computers, servers, etc. And then the final one, Ipatre. So this is a dedicated malware dropper, and it was known most, in fact, at the time for delivering DIA. And obviously, from the previous study, we saw there was this strong correlation between the DIA takedown and Ipatre activity, like dropping like way down. So I thought, okay, let's, even though that wasn't a target in quote, let's still see what happens with Ipatre with respect to that DIA takedown. And yeah, this takedown was an arrest and seizure against DIA in November 2015, led by Russian law enforcement. Okay, so I'm not going to go through all the results, obviously, but like some of the key ones, key takeaways, the takedown resilience and predictability aspect. Surprise, surprise, each malware operation responded differently. But again, interestingly, all of them showed resilience to takedown. And like we've got examples, evidence to show this. So Dridex, this one it faced a DNS sinkhole for 2 months, right? I don't know about you, but me, if a sinkhole is happening, I'm expecting network activity to drop. And we see the exact opposite. It massively increases during the 60-day sinkhole. And what's even funnier is that it increases concentration of servers, specifically in the US and the UK. And these are the same countries that were trying to take down the operation in the first instance. Clearly, they did not. Their activity didn't subside. Dorkbot, our opinion, showed no major changes to its operation after takedown. So you can see the takedowns like this is the brown strip in the around 26th of November. You see a massive drop, right after it. Yeah, granted, but as you can see, it rises again and it has this like cyclic behavior. And to be honest, it looks like there's a cyclic behavior even before the takedown occurred. So this just seems to be like a natural progression anyway. So this is network activity on the left. On the right, you see downloads again, it's more or less constant over the year. Then you get a massive spike of increase of downloads. In fact, it was particularly through Roskill. So again, resilience, if something's staying alive, is definitely evidence of resilience, and they're more than alive. Then the last one is Ipatre. So this one, I think it did show a massive drop. And again, it wasn't identified as the target, but we did see this drop after the arrest and seizure. But then you see several months later, you see that the activity peaks again. And basically what we found was, it was interesting because on the left is domains, on the right is IPs, and they don't actually follow the same trajectory. Domains pop up and stay up, IPs gradually fall down. So I said, okay, what's going on? Digging deeper, I saw that there was a massive change in the domains that they were using for delivery. So earlier on, they were using like Yahoo Mail, AFX.ms is basically Microsoft backend servers for, I think, Outlook, their own email. And these are multi-country, multi-region services. But they moved like a couple months later into like using just alphafile.net. It's a single, I think, is where you could just upload and download software. And this was interesting. This sling2 then there was a bunch of words, like a bag of words kind of thing, and then .ru. For me, blatantly DGA. But yeah, they basically moved to this infrastructure, and there was literally hundreds of those sling2 domains that are being used. This implies basically like a centralization of infrastructure. So when we looked at this, I said, okay, criminology, help me out. What is going on? So they recognize a number of common offender reactions to anti-crime interventions. And 2 that I think are interesting is displacement, number 1. In fact, it's used in so many different fields, psychology, but really is in this context is a change in an offender's behavior in order to circumvent an intervention. So if I lock the door, it's now harder for me to break in, and I'll just go somewhere else and try and break it elsewhere. Or I'll come out another time. There's different types of displacement. And defiance is another one. So this is now an increase in the offender activity and retaliation to the intervention. So if you do something to prevent a crime, I don't like it and I think it's unfair or is basically too much, and I do something even worse. Obviously not me, but you know what I mean. And those are 2 behaviors. And what I believe anyway, but at least for the very, displacement was quite clear. But we think that the malware operators' reactions were characteristics of these models. And obviously there's an assumption here I'll mention in a moment, but now for instance, Dridex ramping up its server usage during the 60-day sinkhole, increase the server concentration. It's still basically, it's clearly alive and kicking. That's displacement. It's just continuous operation elsewhere. Potentially even defiance as well. I think potentially, obviously, you have to say you think, because you can't prove a causal link. But specifically because it was US and UK, they didn't do it in like countries in Eastern Europe, or I don't think they'll go to Africa, if you know. But basically, why did they specifically choose servers in US and UK, where there was like several operations carried out by FBI and NCA? So it's potential anyway. Upatre, it shifted to a more centralized infrastructure several months after the dire takedown. Again, it's displacement. It's moving its operation elsewhere. It's continuing it elsewhere. We don't know why they do these things, and we can't posit why. We can just, speculate. But yeah, what did we learn, and what do we think, in fact, is useful for the community? So really, the key thing here is factoring side effects. In fact, someone wrote a paper on this, and I don't know. I'm sure I don't know if it's Ingolf that you're involved, but I know there's a team in between UCL and probably in Cambridge. They talked specifically about side effects, and I think Ying T trial was involved. But basically, yeah, this is what the data tells us. You need to factor in the side effects to get more effective takedowns. So takedowns occurred. Some of them, there was some, like positive effects in quote, but all of them still survived and it all continued. So if you factor that in, it will revise and hopefully get better takedown strategies long term. And then, of course, this question, it always comes up like this study, but you have to ask yourself, are takedowns the only way forward? Again, this is why environmental criminology I found this interesting, but this evidence, it suggests that obviously takedowns are useful, but it's not the be all and end all in dealing with malware delivery. Yeah.
No, sorry, Colin.
I had a feeling
I mean, we can stay a few more minutes, of course, but it would be great if you could wrap up.
Yeah. Let me round up.
Maybe, I guess.
That's cool.
Great. Thanks.
Give me roughly 7 minutes. I think I'll be done, and everyone can escape. All right. So the unpredictable aspects. This is just new stuff that we saw, no one else has seen, and I'm gonna just fly through it. Dridex is delivering malware secretly. It's delivering ransomware, backdoors, etc. And this has never been, before been seen or recorded. Dorkbot. Basically, what looks to be like potentially like a business relationship emerging. Towards the end of the year, there's a massive delivery of Dorkbot through Ruskill. And again, hasn't been recorded. And then Upatre, there was also a lot going on, but specifically, there was a massive increase in using upstream malware to deliver Upatre to devices. And why they did this change several months after the takedown, no one knows. But yeah, we're the first to find that. And really, yeah, better monitoring techniques, we think that's what the community needs, but specifically correlating multiple intelligence sources. I know we've done some work with that, like text data, social media, but if you could correlate social media with download metadata, with network traffic from ISPs, we think that will help the community long term. All right, I'll run through this. Polymorphism, we saw it was used rigorously by all the malware. Dorkbot evaded semantic systems almost 50% of the time. And what we saw was really interesting is, what we call super binaries, but basically only very few malware were responsible for actually a lot of the activity, especially drop-in activity. Dridex is an extreme example. Less than 1% of the binaries carried out all drop-in activity over a year. So like what we learned is, okay, trying to track hashes and use hashes to detect malware is like, that's a tough challenge itself. So good luck to anyone doing that. But I think focus on super binaries, again, for what's biggest bang for your buck. If you can detect and find these binaries that actually carry out the most activity and disrupt them, then you'll be able to disrupt the malware delivery operations more effectively. And yeah, much more in the paper. There's nothing to summarize there. Maybe a brief pause for any questions. Basically, yeah, I think people want to leave now. So don't worry, we're almost there. We're almost there. So this is the last paper. So now this is bridging information security and environmental criminology. I'm kind of giving you the argument, but yeah, we think InfoSec can benefit from environmental criminology and what they have. What we presented was an overview of environmental criminology research and how it can apply to cybercrime. A survey of cybercrime research from the information security domain. So that's basically what everyone here does. Screen issue again. And then, yeah, what we did, and no one else had done this, funnily enough, before, is just draw parallels between the two and see how similar, once you understand the concepts and you break it down, how similar the two fields look at crime and obviously malicious behavior and how to deter it. Then what we did is basically propose some new potential cybercrime mitigations using these frameworks. Whether they're good or not, that's the kind of another question. But I think the key selling point here is that, one, we found a lot of by using this framework, we did find a lot of the proposed mitigations already used by InfoSec. So that kind of validates that it makes sense. And then what we found is there's basically more coverage. You could think of more types of mitigations using these structured approaches. And that's what we showed. And then finally, just discussed the gaps. What is missing, before we can apply environmental criminology to cybercrime fully? And I think the key concept is, in the real world, we've got place. Everyone knows what a place is. In the cyber realm, what does place mean? What is a location? Where do things meet? And that's what we propose a concept there. Environmental criminology, subfield of criminology, that's the study of crime and criminality. The difference between environmental criminology and the other schools of thought in criminology is that environmental criminology focuses on the crime. Crime is an event. It happens in a place, happens at a time, rather than criminality. So we don't think, it doesn't focus as much on the person who carries out the crime and I want to say the mentality, do that, but in terms of disposition, or the years-long effects that led them to commit crime, it doesn't look at that as much. It's focused on a crime event because obviously that's easier to control. I think that's the main argument. And then follows from there, we focus on proximal causes rather than distal. So what happens immediately preceding a crime or a malicious behavior? What in the environment enables it to happen? As opposed to, again, childhood and things that, comes over the years that leads to that path. And then what it really proposes, the bedrock of this whole field is the 3 necessary conditions for crime. And I guess this is most crime. There are a few crimes that this doesn't apply to, but really most crime is, one, you need an offender, you need a victim or a target, so person or object, and you need a place setting. You need somewhere where this crime occurs, where they intersect. This is commonly known as the crime triangle. Crime triangle pops up in multiple places. Basically, is another way of talking about the crime triangle. And environmental criminology basically says that if you can affect one of these dimensions, so either the offender or the victim / target or the place setting itself, and do some sort of manipulation. Manipulation is kind of a hard word, but basically do something to control one of those dimensions. You should be able to influence the probability of a crime occurring, and ideally reduce a crime event, or the probability of a crime event occurring. There's been a huge evolution of this work, of this field over the last couple of decades. I'm just going to give a quick summary of, literally 2 minutes, of the most interesting ending for me, theories and frameworks. So routine activity is again, is core to a lot of this. Is a macroscopic theory that basically states crime follows opportunity. The more opportunities there are for people to commit crime, like no one uses locks on their doors and houses, their shops, it's more likely there's going to be an increase in crime. That's what they're saying, basically. Formally, it basically repeats the same thing of the crime triangle. Slight difference is talking about the absence of a capable guardian. So when an offender and a suitable target meets, there's not something or somewhere there to prevent the crime occurring. And these 3 things is necessary for direct contact crime to occur. Real world examples and how routine activity theory explains them. Sexual assaults are more common in the night than in the day. This is well-known facts, known for decades. Reasons, well, again, think about opportunity from an opportunity perspective. Nighttime is more obscure. So obviously, both in the favor of the attacker carrying out an attack and no one else seeing it to prevent them. People are drunk more at night. Both, again, offender and the victim and even the protector. If they're all drunk, they're all okay, or not all drunk, but basically any of them being drunk can lead to increase their likelihood of sexual assault, and so on and so forth. I think you get the idea. This one always makes you laugh. But Land Rovers are the most stolen vehicle in the UK. Range Rover second most. If anyone knows about these cars, you know that the security technology, I don't know. As of today, it may have changed, but as of yesterday, it's been terrible one. Criminals have picked this up, and that's why they target them, as well as them being high value assets. And then we've got digital examples. Bot activity I just showed you in the first piece of work. And computers, they're only vulnerable to, well, at least most malware infection methods that are connected to the internet. So this is clearly opportunity enables a crime. Deny the opportunity, the crime can't occur, the malicious behavior can't occur. So you see the parallel there. Situational crime prevention is a framework basically premised on offenders being rational actors. Not always true, but I think most of the time, most people are rational actors, even if unconsciously. And the next premise is offender decisions are influenced by the immediate environments. If a car is coming your way, you're most likely going to jump out of the way. So that's basically what it's saying. And of course, for offending as well. So this leads to crime can be deterred by manipulating the environment. And if you've ever seen the meter attack framework, is very similar. I don't know, in fact, if they're related, but situational crime prevention outlines 5 different tactics, left to right: increase the effort to commit the crime, increase the risks, reduce the rewards, reduce provocations, remove the excuses to commit crime. So these are general tactics. And then with each of these, you've got like a list, or basically multiple techniques you can do to achieve each tactic. I'm not going to go through them, but basically this is like a high level framework of how you can assess that crime event, an offender, a target, and an absence of capable guardian, and see what you can do to, again, control one or more of those dimensions. And that's exactly what I did. So really, I just said, okay, let's apply this to the malware value chain. This is proof of concept. And I'm not going to go into the details, but really malware value chain, I just is a high level one, looking at the stage by stage of all the way from malware creation to delivery, and even after delivery and malware does, the malicious stuff on computers, what happens after, because there's secondary crimes that occur. And when you just basically do this overlay, you'll be surprised that ideas are pop up. Some of them already exist, which is fine, but then we find a lot of other ideas. I don't know so everyone knows about vulnerability bounty programs. I don't know if malware bounty hunting programs are as popular, or if anyone knows about that, but I didn't see anything like that. But it's where potentially you have research, trying to look for malware. And in fact, there is something that's popped up recently. Identify vulnerabilities in malware that could be exploited or be used as part of, protection system. So obviously that's in the paper, but that was what I proposed. And there's other mitigations, new ones as well, but I just included this one related to the thesis. And the last thing, I'm only spending like 20 seconds talking about this, but I proposed the Cyberplace concept. If you think about place, we don't really need to think about it because it's intuitive. But when you look at the definition of place, and there's 2 papers there that corroborate it from geography and philosophy. There's like 3 components to a place. Like location, like the GPS location. But a restaurant is not just a bunch of coordinates. It's more than that. It's a building. You've got tables, you've got etc. So that's the locale. That's the material setting. But then even beyond that, a restaurant is more than there's a sense of a place. People go there to eat food, and people know you go here to eat food, to drink. You have memories, you have emotions. You don't go to a restaurant, to buy a house, or So that's what I'm saying. That's part of place definition. And basically looking at, I think it was at least 30 cybercrime examples, as well as this concept, basically provided evidence and broke it down. But yeah, that's basically it. So in terms of the answers, I think I can round up, because everything I'm saying here, I've already said it, is really just a summary of what we found. And obviously what I presented in the thesis. Yeah, let me just round it up here, because I think everyone wants to go. Let's leave it there. Thank you all for listening. Any other questions, I'm happy to take them. Otherwise, we could take this offline as well. So details are there. Cool, thank you.
Great, thank you, Colin.
All right, no worries.
Great presentation. Any questions? Maybe from Gianluca. Yeah. I'm going to put him on the spot and ask him to ask you.
Yeah, how did Gianluca deal with me for 4 years? That's
a question, I guess. If you had to give advice to, no, I mean, if you had to give advice to someone starting their PhD right now in the same space, what would you tell them? What kind of promising directions or open problems do you see?
That's okay. Good question. I know I've actually wrote this in the thesis, but I think there's 2 directions here, and it's kind of like as a result of the work. So if we focus on more on the malware delivery side and the technical direction there, I think from what we found, and not just in my work, but other works I've seen this, and in Ray 2021 we saw other works see this. So like these benign services are being abused. We saw that they're core to a lot of the abuse. Google and all these other big services. Obviously, something needs to be done there, whether it's research partnerships, or whether it's literally just, I wouldn't call it whistleblowing, because, but there's I think there's an opportunity, I think, for at least partnerships there. In terms of actual research, I think there's still a lot. The potential I wanted, malware is always going to be an interesting issue, and how to deal with malware. And of course, if any of these frameworks that I've talked about, if they can be applied realistically. I think one of the things that we don't really see as much in information security, like in the detection prevention, is like we do like target hardening. You make it harder for someone to get access to a device, but like removing the value of something, like make it so it's not even worth the operator's time to try and break into it, and even if they get access. So I know looking into that obviously is kind of a mix of the technical aspect. But yeah, I think the other thing of the potential unwanted programs is definitely another area of interest. And I think there's a lot of research starting to go into there. But understanding the links, if there's a chain or link between potential unwanted programs delivery and malware delivery, because potential unwanted programs is far more prolific in terms of downloads. At least that's what we saw. Then I think the other side, and I think this is the remainder of my answer, is this socio-technical aspect of cybersecurity. So cybersecurity is not just computers and computer scientists, it's people. People use the devices, people is related to security. So you need that understanding. And if you need to look at both the technical side as well as how people use technology, how they relate with it. I think that's a really interesting area. I think that's going to be, at least from my research, especially that last work took me all over the gaff. It really does look at is